Good morning, children. Today I am here to deal with another topic in the mathematics, that is called trigonometry. Last class previously we have learnt it on polynomial as well as the arithmetic progression. So today we will discuss another chapter in the mathematics, that is trigonometry. Basically, as you know that because the trigonometry is a new concept for class 10 standard, but the basic part of trigonometry is related to even the previous classes. That is, look at the definition and the trigonometry meaning. Here is a trigonometry, very clear. It shows that the meaning of tri is 3 and the gno, which is called sides or an angles. The metry, the measure, that is measurements. Metry is nothing but measurements. Very clearly it shows that three sides are an angles measurements. Trigonometry, which gives a meaning of three sides or it may be an angles, its measurements. So three sides are an angles. The meaning very clearly, as we have stated earlier, the three-sided figure are three angles in the geometrical figure, which is the only, that is a triangle. That is a triangle. As you know that the triangles, this is a triangle ABC, and we have learnt it at different triangles which based on its sides as well as an angles. Here it is triangle ABC. If I mark here, it is, you see that, so all the sides are equal, then you can say that it is an equilateral triangle, which is called equilateral triangle, as well as if at least two sides are same, one is different, you know that it is an isosceles triangle. The another one is if all three sides are different measures, then you can say that it is a scalene triangle. These are all based on their sides as well as the angles. As you know that if all the angles of a triangle are less than 90 degree, all the angles of a triangles are less than 90 degree, that is called an acute angle triangle. If one angle is exactly 90 degree, the other two angles are less than 90 degree, because as you know that the properties of the triangle, the sum of the all three angles of a triangle must be on 180 degree. Similarly, here it is, this is a 90 degree. We call it as a right angled triangle. Then the another, see that the measurement acute angle triangle or right angle triangle, the one angle is more than 90 degree. The one angle is more than 90 degree. That the triangle is called an obtuse angle triangle. These are all triangle ABC and ABC. You see that here it is, the trigonometry stands on basically the triangles, but you must understand the types of triangles as you have studied in the class 8, the previous class 9 standard also. Here the triangles are based on categories, you see, classified. It based on sides as well as it's based on angles. Here it is the equilateral because all the sides are equal, any two sides are equal, isosceles, and all three sides are different. Then the different measurements is called as scalene, as well as in respective with an angles. Then this is an all the angles are less than 90 degree. This is one angle is 90 degree, other two angles are acute. You can say that is a less than 90 degree. And here the another triangle is obtuse angle triangle. Here it is more than 90 degree. So this is a basic what we have learnt it in the last year or previous classes. of different types of triangles and all. What is the relation, the connection between trigonometry and the triangle? Because as you know that here I have given the definition of trigonometry, the three sides and angles, the only figure which comes under three sides and angle, that is a triangle. But in the trigonometry, here is a measurement, meter is a measurement. In the trigonometry, when we are learning a trigonometry, majorly we are taking the only triangles, which because it is having the three sides as well as an angles. So now we will go for the three sides and angles. Basically, after learning this basic concept of that, so we will restrict, because we are going trigonometry. The another part I will give it here. This is a figure which gives very clear information. See that the triangle here, it is all S and T and C. This is in higher classes syllabus. So why we are restricting only the first part? This is called the first quadrant. We are learned in the graphical conditions. First quadrant, second quadrant, as well as the third quadrant and fourth quadrant. The first quadrant gives all are positive. Here it is x-axis and y-axis both are positive. But whereas in the second and the third and fourth, the quadrants, they are different conditions. One is a minus and plus, both are minus, as well as a plus and minus, so on. So here it is, we are restricted only this part, that is the first quadrant. Now basic in the trigonometry, we are learning only in the first quadrant of triangles, that is it comes under a right part, because it is a right angled part. That's what we are learning, only a right acute angled triangle, because this is a right angled triangle. When it is a right angled triangle, the other two angles are acute angled triangle. This is the concept of, basic concept of the trigonometry, the meaning and the basic triangles and all. Now we will move on the definition. The actual definition of trigonometry, which is it's a branch of mathematics. The trigonometry is a branch of mathematics which deals with the relationship between, the relationship between sides and angles, its measurements. See, I told this is, we are restricted, I told this is a right angled triangle. This is a right angled triangle where the right angled part, right angled triangle ABC. The right angled part is angle B, is a right angle part. Now this is angle C, you can treat as angle C, and this is an angle A. Very clear, we show that here it is, this is the longest side, the AC is the longest side, this is called the longest side, and BC is the base or an adjacent side, when if we are considering angle C is a base angle. The same thing, if angle A is a base angle, then this will be an adjacent. If I am treating this is an angle, the angle is opposite side. This is called an opposite side. The base angle which we are going to learn, angle C, is the name of the angle. I give it in the trigonometry, that is called an theta. It is a theta, Theta, which is a theta. When we are learning angle C, that is a theta, so meaning is its theta's opposite side is an AB, its base angle is either an base or an adjacent, and the longest side, as I told, a hypotenuse. Even this right angle triangle property, we have learned it in the last year, that is a previous class, which is called the Pythagoras theorem. A very beautiful theorem in the right angle triangle property. What Pythagoras says that in any right angle triangle, triangle ABC is a right angle triangle, definitely the sum of the squares of the triangle is equal to its square of its hypotenuse. This is the formula, a beautiful formula is given by the Pythagoras. Very clear, shows that AB square plus BC square is equal to AC square. Here you can find the length of AB as well as the base of BC and the longest side of the triangle, which is an hypotenuse. Now come back, as I told, this we are considered as base, then its opposite part of the side of the triangle is called an opposite side. opposite side, and where theta is there at the base, either adjacent side or you can say that at the base, and this is an hypotenuse. Now the trigonometry, the main part of trigonometry, the basic fundamental, we are restricted, as I told, two angles are acute. One is a right angled part, because the sum of the triangles, see that the sum of the angles of a triangle must be a 180 degree. Angle A plus angle B plus angle C, which is equal to 180 degree. As I told here, so if it is a theta, as I considered this is a theta, then definitely angle A is 90 minus a theta, because already one angle is a 90 degree. When C is a theta, C angle is a theta, plus angle B is a 90 degree, very clear, then angle A will be a 90 minus a theta. So angle A plus angle B plus angle C, a plus 90 and minus 90 get cancelled. See that it is plus theta and minus theta. So 90 minus theta, sorry, 90 plus 90, which is 180 degree, a plus theta and minus theta get cancelled. When it is 90 plus 90, which is equal to a 180 degree. So hence the result of the triangle, the sum of the angles of a triangle equal to, that is 180 degree. So therefore, according to that, if one angle is theta, the another angle must be less than this angle, that is 90 minus theta, because already this is a 90 degree. The concept is very clear. If this is a theta, so definitely this is 90 minus theta. Once if the triangle is drawn, if this is on base, for example, here it is on 90 degree. If this is theta, very clearly this is on opposite side. Then definitely this is a base. And this is the longest side, which is a hypotenuse. This holds good that sum of the angles of a triangle, which is equal to 180 degree, either you can change the theta as base angle, or see that 90 minus theta as also a base angle. You can convert, you can find out in different questions in the trigonometry. So completely trigonometry stands on the triangles, because it having a sides as well as an angles, that to be three sides and angles, because it's the relationship between the trigonometry is mainly the relationship between sides and angles of a triangle. That's the definition of trigonometry is, it is the measurement of, definition, the measurement of three sides and angles measurement is called trigonometry, and the angle which is denoted by this is on theta. Basically the trigonometry is derived from a Greek word. This is trigonometry stands, see that it is a Greek word. The first who is introduced this, the trigonometry part, is called Hippocrates. So slowly when it studied, see that the triangles and its properties, and in the right angle property as well as acute as well as this all the thetas and all, then it is given by actually the Indian mathematician, which is called he is an Aryabhata. In his book, it is mentioned the sinus, which is the name is the sinus. The meaning of sinus is in the Indian word in the year of 500 AD, who is Aryabhata. The book name is called Aryabhatiyam. So in the year 500 AD, the word is introduced as sinus, which slowly that will be converted into, we are calling now, it is a sine. One of the major part of the right angle triangle property, the sine, the ratio, the sine shows that the ratio between the ratio of the triangle, which is, you can see that in the right angle triangle, you can write it the possibilities of their ratios. As we know that the corresponding sides of the angles are equal, or corresponding sides of the triangles, you see that they are proportional, or sometimes their ratios are equal. Similarly, in the right angle triangle, here it is, when we are going for ratios of the right angle triangle, so you can write it in a different ways. See that the totally there are three sides are there. One is AB, BC and AC. There are three sides are there. Into every time when you are going to write a ratio, we need at least two sides, any two sides. So it means that the totally 3 2s are 6. The ways are possible ways to write down ratios of this right angle triangle. Similarly, just I'll write it. One is you can take it as AB and BC as one ratios of their sides, as well as AB and AC are another ratios of the sides, or BC and AC as one more ratio of the sides, and AC AB as well as AC BC. So if you convert like this, there are possible ways. There are 6 possible ways to write the ratios of this right angle triangle. Similarly, when Aryabhatta says that the sinus is it is called an ja in the Indian language. It's called an ja or ardha ja as well as an koti ja. Slowly, the people of Indians, they solved this using this condition. Then he says that the sine of an angle. Here it is a sine of an angle. What angle you are going to write? Either in theta or in C, because if this is a base angle, we have considered this as a base. So either you can write sine theta or sine C. Both are possible. Here we have taken as sine theta. So sine theta will be given the sides. You see that as I told, the ratios of the right angle triangle. In the right angle triangle, the sine theta can be written as, see that the sine theta can be written as by hypotenuse, which is opposite by an hypotenuse. The sine theta, sine angle this theta is given by the opposite by its hypotenuse. Similarly, another mathematician, he introduced that the trigonometric ratios, that is an cos theta. Cos theta says that, see that the cos theta will be the another ratio of the triangles, see the sides of the triangles, that is the base by and hypotenuse, or you can say that the adjacent by hypotenuse. So slowly all the ratios of the trigonometric ratios in the right angle triangle is introduced by Edmund Gunter. So he says that all the trigonometric conditions are satisfied under this. So when it is a right angle and other two angles are acute angled triangle. That's very important. This is not a product. Another thing I tell you, the sine into theta is not a product. It is a sine, the angle. Which angle we are going to consider. If it is a base angle, then definitely this will be a sine theta. If this is a base angle, definitely it will be a sine angle A. So you can pronounce it sometime. It may be a theta or sometimes directly the angle of which they are given the point. You see that in a right angle triangle, the ABC sine angle C. Similarly here, the tangent theta. It is a shortcut, you can say that it is a tangent theta or tan theta. The tan theta will be the ratio of the other sides which is opposite by the base. Very clear, students, you can see that if you know these three trigonometric ratios, opposite by and adjacent, or you can say that the base also, the base, here it is adjacent, both are there, you see that. Look at now the sine, the cos, the tan, these all trigonometric words are introduced by the mathematicians. Later on it went on all 6 trigonometric ratios. So here it is, the sine is nothing but the opposite by hypotenuse, the opposite side where the theta is there, the base angle, its opposite side, and divided by the hypotenuse, and the cos is the base by an hypotenuse, and the tan is the opposite by the base. Let's look at the ratio. How nicely we have to see that. The first one is the opposite by hypotenuse, the second one is the base by an hypotenuse, the third one is opposite by an base. Because if you observe that the opposite and the base, both the hypotenuse get cancelled, meaning is the sine by cos is equal to the tan. You can relate the terms, which is the sine theta divided by the tan theta. See that cos theta is equal to, you can write it as tan theta. Similarly, the sine theta, its reciprocal term, the another one is that is called a cosecant theta. The cosecant theta can be written as, I told the reciprocal of opposite by hypotenuse, its reciprocal is an hypotenuse by an opposite side. Similarly, the cos theta, it is cosine theta. So shortly we are telling it as a cos theta. Here it is cos theta reciprocal is, and secant theta. The secant theta its reciprocal is, and hypotenuse by, you can treat either in base, that is hypotenuse by base. And at last, you know the tan theta, the tangent theta, and its reciprocal name is called cotangent, because tangent and a cotangent. The tangent theta, its opposite is a cotangent. A short form it is called an abbreviated as only cot theta. The cot theta is equal to, you can write it at the base by opposite, where I told the reciprocal relations of the trigonometrical ratios. So this is very clearly show that, look at once again, as I related the sine and the cos relation, sine by cos is equal to tan, because both the hypotenuse get cancelled, the opposite by base is there. Similarly, the cosecant by secant is equal to, that is one cot, because now look at here, both the hypotenuse can get cancelled, the opposite by base is there actually, but they are in the denominator part. The denominator goes to numerator, that is a base by an opposite, which is the exactly the 1 by of the tan will get an cot, or 1 by of cot will get an tan. So that is the relation between the trigonometric ratios of the different sides. You see that all the three sides of the right angle triangle property. This is the main concept of trigonometry, where we are deals with a three-sided, and with respect to their angles, the relationship between the sides and angles of the given right angle triangle. Its measurement, sometimes you can measure the triangle, the angles, or sometimes you can measure their sides. So it depends on the question. So here it is totally the three-sided figure, which is called a triangle. As you know already, its angles and sides, the measurement, that completely gives an idea of trigonometry. Let us take the uses of trigonometry, because we are learned only the trigonometry, mainly we are focusing on only the right angle triangle, where other two angles are acute. I said here it is the ratios of the trigonometric ratios. I have given all the 6 trigonometric ratios are there. The uses, the application, because applications of trigonometry, where do we use this trigonometric concept? Because this is a trigonometry is such a subject, it is a very important topic in the whole mathematics, and in the higher classes, when you go to the 11th and 12th standard, it gives a very vast knowledge and a very beautiful concept in the mathematics. This is a very beautiful concept in the mathematics, that is the trigonometry. Go on learning, it will be very interested and very creativity, because just I tell you the features of the trigonometry part. First, the uses. You see that normally we think that where do we use the trigonometric conditions? See that in the general condition, just I tell you surrounding us, you know well, in the I am talking about on the Republic Day or on Independence Day, there is an, see that this is a flag post, as you know that, yeah, this is a flag post where all the children will gather over here. The boy is standing near the flag post. He is here. The boy is standing near the flag post. Yes, the boy is standing near the flag post. He want to salute on the Independence Day. I can say National Festival, that is on Republic Day also. Yes, the Republic Day. Now he is looking towards a flag post. He is looking towards a flag post. See that beginning, we don't know the height of this flag post, because the boy want to measure the height of the flag post. When he comes towards the flag post, earlier the distance, you see that the distance, this is a platform. Yes, this is a platform. When he come towards a flag post, how far is there here? He walks towards flag post, or he can move from away from this flag post also. You can treat it. So suppose if I say that this is an almost 200 in terms of feet, I consider 200 feet. So when he walks towards that, very clear, this is called an height of the flag post. Height of the flag post. This is an base ground. Can say that this is a base where the flag post and a person, a boy, are standing on the ground. you see that he is looking towards this side. Now he want to calculate and what angle he is looking. Here you can mark it as at what angle. This is an angle formed by here as well as in here. Very clearly, if the boy is looking towards this side, if boy is looking towards this side, is called an angle of elevation. Angle of elevation. So very clearly it shows that the diagram the diagram it very clearly shows that it is a right angle part. Where the boy is looking towards the flag post, the angle, the inclination angle, you see that is the angle of elevation. Where this is the theta, if I consider, then definitely you know this is the height as well as base. It is called heights and distances. You can calculate heights and distances by using trigonometric conditions. See, the person is looking towards, when he was on the road, this is a river, and then bridge. The bridge, if here the observer is here and the object is here if he is looking towards a downwards, the condition, that angle, which angle is formed, that is called depression. This is an angle of elevation. As I told, it is an elevation. When the person is on the bridge, he is looking towards towards a downwards, where the object is there. That object is finding here, the angle is finding from his eyesight to an object, that is called a depression, which is you can calculate by using, because you see that if I draw a straight line here and the base I consider as the base part where the object and the observer where he is standing, so this is called a base, and here it is the height of the person, and this is angle of depression. So angle of elevation, angle of depression, as well as the sides of the right angle triangle. See, as I told, the sides of the right angle triangle, there are plenty questions are there. The application based questions on the trigonometry, daily life you can see in our surroundings. There are many examples you can consider. Also in the next class we will go for that application based and all. Now basically the concept, the first basic concept of our class is the trigonometry. This is the basic concept where all the 6 trigonometric ratios are called. Here it is these are called 6 trigonometric ratios. You can relate it their reciprocal relations also. You see, the sin theta can be written as its reciprocal relation is 1 by cosecant. You can write 1 by cosecant theta, as well as see that cos theta can be written as cos theta is equal to 1 by secant theta. So similarly, here it is just I will write and I will write it the reciprocal relation. Yeah, look at the tan theta can be written as 1 by cot theta, and cot theta can be written as 1 by tan theta. Similarly, the cosecant theta can be written as as I told 1 by sin theta, where sin theta is 1 by cosecant. Definitely the cosecant can be written as 1 by, see that if we cross multiply, see that the sin theta will come to denominator of the other side, that is a cosecant theta can be written as 1 by sin theta, as well as the another one is secant theta can be written as 1 by cos theta. It is all called a reciprocal relations of the trigonometric function. Reciprocal relations. This is the identities or the features of the angles you can find by using the right angle triangle property, but the mainly we must focus on the 6 trigonometric ratios, their reciprocal relations. Not only this, even some more identities you can formulate by using this reciprocal relation, as well as by using this as trigonometric conditions, that is ratios of the trigonometric conditions. So basically this is called the basic fundamental or introduction of the trigonometry. I hope a very clear concept. The right angle triangle where the base angle is theta, the another one is 90 minus theta. As I told you want to write it, you can write it. This is a 90 minus theta because the sum of the angles of the triangles must be on 180 degree. So this is 90 degree and the theta and 90 minus theta, both the theta get cancelled. 90 equal to 180, that is plus addition of the 90 plus 90. So this gives more information, as well as this right angle property. As I told, basically it is given by the one of the great mathematician who is called Pythagoras. Yes, Pythagoras' theorem, as I told just now, for this right angle triangle. In this right angle triangle, I am talking about only this right angle triangle, the AB square plus BC square, which is equal to AC square, the sum of the squares of the two sides of the triangles, which is equal to always equal to the square on its hypotenuse. As I told you, the longest side, that is a square on its hypotenuse. Using this basic concept of right angle triangle, using this basic concept of theta and 90 minus theta, so we are going to learn the trigonometric ratios. So the formulas, these formulas are very interesting, as well as you can understand very clearly what are their sides, the ratios of their three sides of a triangle, as well as you can calculate even angles in the higher classes. Sometimes it will be a theta plus another one, maybe a 90 plus theta, or 180 plus theta, or 270 plus or minus theta, or 360 plus or minus theta. It comes under, as I told beginning, that is a four quadrant. The first quadrant we have taken, that is only all are positive, because it's an only all the six trigonometric ratios satisfies under the first quadrant, that is all are positive. But whereas in the second condition, it is 90 plus or minus theta, as well as 180 plus or minus theta. Look at, once again I give it here. This is up to 90 degree. This is called up to 180 degree. This is 180 degree. This is up to 270 degree, as well as up to 360 degree. This is first quadrant, or second quadrant, and third quadrant, as well as and fourth quadrant. So basically we are learning only in the first quadrant part. In higher classes you can find the second and third, fourth quadrants also. Whereas here we are learning only up to complementary, not a supplementary. So complementary, the sum of the angles, any two angles gives that is not even 180 degree. If you go on 180 degree, that gives us supplementary. But the first part we are learning only the complementary, which is this is a 90 degree. So exactly the first part is all are positive. As I told beginning, here it is all are positive. Here nothing but all the six trigonometric ratios satisfied the positive condition, because as you know that this is an x-axis as well as y-axis. This is a positive numbers, 1, 2, as well as so on the numbers. Even similarly here, the first quadrant you can measure it. So both the x-axis as well as the y-axis are the positive. So that's why we are going to learn the trigonometry only. We restrict, because class 10th standard syllabus we have only the up to the first quadrant. Then in the higher classes we have in second, third, respectively the other quadrants also. But here in the class 10th standard, so only the right angle triangle property, and as well as the basic concept of ratios, trigonometric ratios, and their reciprocal relations. Some more identities are there, as well as I told in the first quadrant, the complementary angles are there, and the application based questions are there in your syllabus. So we'll go for one by one with the first exercise. When we start, I think this is very clear information what I am giving here. So we'll go for the first exercise, where the first exercise gives very simple questions. I think it's very clear the trigonometry meaning and the ratios. Yeah. And their reciprocal relation, that is very important. The reciprocal relations are also very important while learning the identities questions, because there the question comes to prove that, or sometimes to show that the LHS and RHS, or sometimes to prove that the question there will be identities. While solving an identities, all the ratios as well as the reciprocal relations, the relations between the trigonometric ratios are very important. Look at, we are going for exercise, the first exercise, which is, I think it is 11 point. which is 11.1. What I am going to discuss here. This is exercise 11.1. The first question very simple. It is very big question. Just I read out so you can see the textbook later on. In a triangle ABC, right angled at is given as B. In a triangle ABC, see, look at, in a triangle ABC, right angled at B. This is a triangle ABC, right angled at B. AB is equal to 24 centimeter. This is AB. The value of this side AB is given as 24 centimeters, and the BC is equal to 7 centimeters. The BC value is given as 7 centimeters, and determine the question is sin A cos A. The questions are sin A. The questions are sin A into a cos A. This is a first question. And the second one is sin C into cos C. The second one is sin C into a cos C. Look at very carefully, because here it is in a right angle triangle. You must see that AB and BC are given using the Pythagoras theorem. As I told, whenever right angle triangle is there, this is an triangle ABC. As you know that previously I told the Pythagoras theorem, he says that the square, sum of the squares of the two sides, which is AB square plus BC square, is always equal to the longest side of the triangle, which is hypotenuse. As you say that it is an AC square, the AB value is given as 24 square plus BC value is given as a 7 square, which is equal to AC square, because we need to calculate the value of AC, where 24 square, I think it is a 576 plus 7 square is 49, is equal to AC square. Therefore, a AC square is equal to 576 plus 49. Very clear, it shows that 625, because 9 plus 6 is 15, carry 1, 8 plus 7 plus 4, 11, 12, again carry 1, 5 plus 1 is 6. So AC square is equal to 625, but we want only AC, that is square root of 625. I think you can understand the square root of 625, that is 25. You don't write plus or minus. Normally the square root of 25 we write plus or minus, but here the exact value, because it is the measurement or distance between A to C, that is 25 centimeters. Now look at the question. The question is very interesting. The sin A into cos A. Here in place of theta they have taken angle A. This is sin A cos A. Whereas the second question, if you observe, so instead of theta they have taken C, angle C, sin C and cos C. Look at this triangle is very important. I draw two varieties of triangles. One is, suppose if this is on base, you can consider as this is theta. If this is the base, if this is on base, this is on theta. That's what the sin A and cos A, when you are calculating sin A and cos A, so the triangle is, this is a triangle. I can say that another diagram I am drawing here. This is an angle A, the B and C, or you can say that this is an angle A, B and C. Look at the same triangle, the same diagram I am drawing in this way because it is easy to understand. I told this is an, suppose if it is base angle, its opposite is BC. AB is a base angle, because the question is sine of the angle A, then its opposite is BC. Similarly, when it is sine of C, then the base is C, then its opposite is AB. Try to understand the first and second question. This is an angle A and this is an angle C. Angle A is here, angle C is here. When you are considering angle A as base, definitely this must be an opposite side, because this itself is a base angle and hypotenuse remains the same. When you are considering for second question, the angle C is a base angle, its opposite side is an AB. So because previously I told this I have considered as theta, sometimes this is a theta. Then if this is a theta, this is 90 minus theta. Previously one example I have given there, the right angle triangle, the base is a theta. Here it is the base, the first question, base is angle A. When this is on base, then this is opposite. Try to understand. When that is on base, then it is an opposite. So therefore sin theta, sin angle A is equal to, sin angle A is equal to, the first one I am solving here, sin angle A is equal to, now it is, this is a hypotenuse. When the sin angle opposite by hypotenuse, which is 7 by 25. 7 by 25, because this is on base angle now. Similarly, the cos can be written as, the cos theta is equal to, now cos theta is equal to base by hypotenuse, because the sin is an opposite by hypotenuse, which is cos is the base by hypotenuse. So cos theta is equal to, or cos angle A, here it is mentioned as cos A, cos angle A is equal to the base by hypotenuse, which is a 24 by 25. The base by and hypotenuse, which is 24 by 25. Therefore, according to the question, the sin A into cos A. The sin A is 7 by 25. The sin A is 7 by 25 into, because it's a product, a 24 by 25. As you know the product, a 7 into 24, I can write it, the value, which is, they asked I think separately, not the product. So here I am going, which is product. No, the question is only individual question they asked. One is sin A as well as cos A. It is not a product. It is not a product. See that it is a comma is given in the textbook, which is first value is sin A, second value is cos A. The second question is a sin C. Now look at the value of sin C here. The value of sin C, this is the base angle, as I told. Now we will remove this, is the opposite, hypotenuse remains the same. Look at the diagram. Now the angle C is base. When angle C is a base, this is a base angle. Definitely this will become an opposite, because base is BC and hypotenuse remains the same. Then angle sin C is equal to, now the opposite is AB. Earlier it was different. Now the opposite is AB. I will write better to clear that. Opposite is AB, hypotenuse is AC. AB by AC, that is opposite by hypotenuse, which is 24 by 25. Which is 24 by 25. Whereas if you see the previous one, here the answer we got, that time the sin A is equal to, this was on base by that time. Not this C as a not base. A was on base by that time. So we look at this it's an the base angle. Then opposite is BC. BC by AC we have taken, which is BC by AC. But now when you are calculating angle C, then the opposite is AB. When you are calculating angle A, this is most important, which angle you are going to consider, whether angle C or an angle A. If this is a base angle, its opposite is AB. If this is a base angle, its opposite is BC. So similarly, here it is, the sin C can be calculated by opposite by hypotenuse, that is sin theta. I can say that opposite by hypotenuse, that is 24 by 25, and another they ask, that is cos C, cos angle C. The cos angle C is equal to, which is, now it is base by hypotenuse. Now base is 7 by 25. Now base is BC. I can write it one more step. The BC by and AC, which is 7 by 25. Children, this is the way to calculate the trigonometric ratios of sine, cos, or any out of 6 trigonometric ratios can calculate. The first thing is, you must understand the sides of the triangles are given. If two sides are given, any two sides, either it may be a hypotenuse or opposite or in base. So by using Pythagoras, this is very very important, because Pythagoras, he has given tremendous the formula, as you know, that the sum of the squares of the two sides of the triangle is always equal to its longest side. That name is given as hypotenuse. So here it is AB square plus BC square is equal to AC square, because if you use this formula, then only it is easy to calculate the another side, which is unknown side is given, because two sides are given. The third side, which is not given, that will be calculated by using this condition. Then so you will get the third side also. Then after getting all the three sides, because we must know that when trigonometric ratios are there, all the three sides are there. See that the relations between all the three sides, not only for only one or two, or opposite by hypotenuse, not like that. So all the three sides are there, then only it is easy to calculate all the six trigonometric ratios. So today this is the first exercise we have taken. One example question, you see that 11.1, I think the first question. Please go through the textbook. The question is given very simple. In a triangle, right angle triangle ABC, where the angle B is on right angled part, and the other two sides which are the opposite end at the base, or sometimes it depends on, you don't write this is an opposite or this is an base. It depends on the question, because here it is the sin A and cos A, sin C and cos C. They asked separately. One is an angle A and angle C they asked. So when angle A and when angle C, when angle A is there, then you think that this angle A its opposite will become BC. When angle C is there, its opposite will become an AB. The hypotenuse remains the same because it's the longest side in the triangle. That is right angle triangle. The opposite of right angled part is always an hypotenuse. This is very important concept. So trigonometry, as I told, is a very beautiful concept in the mathematics. It's a branch of mathematics which deals with basically it comes from Greek. So some terminology, and I see that. So which is very important part. The applications I told, applications also very useful for applications in our surroundings, in our daily life. You can see that. So slowly one by one we'll go through that. So today we are going 11.1. In that 11.1, the first question is given like this. So we'll move on even second question. So tomorrow we'll continue with this second question. Tomorrow we'll continue 11.1 because another class is there.